So next concept in our course in the graph theory unit is spanning trees. So in the last video we have studied about trees. Let's see what is spanning tree. So we have already seen that if G is a graph, right? If in this graph there are no cycles, there are no circuits, okay, no loops, right? Then we say that particular graph is a tree and it should be importantly connected. So in a graph G, if there are no cycles, no circuits and no loops, and after that also it is connected, then we call that kind of a graph as a tree, right? Now what is this spanning tree? Let us take an example. This is a graph. It has 4 nodes. This is a graph. It has 4 nodes, right? So a spanning tree of G is a subgraph of G. It is a subgraph of G that is a tree containing every vertex of G. So somehow I should generate a tree from this graph G. I should generate a tree from this graph G, such that when I generate a tree from this graph, that tree should contain all the vertices. That tree should contain all the vertices, and the graph should be connected graph. Okay, so in that order, if you see, if I can remove this vertex, if I see, I have a graph like this. So this can be called as a tree because it has no cycle. I have removed that one edge which was forming a cycle, and our definition is it should not contain any cycle, no circuit, no cycle, no loop. So this was by removing this, maybe I will take A, B, C, D. By removing edge A, D, I formed a tree. But we have multiple options, right? I may also have like this. This also can be a tree, A, B, C, D. By removing B, C, you got another tree here, right? What all other possible? I may get a tree like this by removing AB, by removing this, or I may get another tree of this format by removing this edge CD, right? So we are getting multiple trees here. Okay, so this is one concept. What is spanning tree? Spanning tree is a subgraph of G having all the vertices and forming a tree. Okay, it is a tree. Tree means it should not have any cycles or loops. For that, we have to remove some edges, maintaining all the vertices in that particular tree or in that graph. So we got 4 options. So if I have a graph like this, I am getting 4 spanning trees. Okay, I am getting 4 different spanning trees. Now there is something, the next concept before we understand what is this is weighted graph. Weighted graph. Okay, what is this weighted graph? Okay, in a graph like this, okay, we may have sometimes the weight on the edge. Weight can be anything. Maybe that weight is indicating the distance between the 2 nodes, 2 cities, or suppose if I have here 5, some 10 or 9 and 3. If I have something like this, this number 5 can be distance in kilometers, can be price per kilometer, or can be the time taken to travel from A to B. It can represent any parameter. It can represent any parameter depending on the problem. Okay, so graphs which have some number on the edge, okay, those are called weighted graphs. Okay, right? So you see this example, in this example, if you see, if I put here 3, 2, 1, 4, 6, 7, 1, 2, 3 and 4, if I put some numbers on the edges, then this graph becomes a weighted graph. It becomes a weighted graph. Okay, so normal graph and weighted graph, we need that because we need to understand how the concept of spanning trees works. Now when you have a weighted graph, right, see, for the simple example, A, B, C, D, let me put some weights 2, 3 and maybe some 3 and 4. Okay, I have kept some weights here. Let me put 1. Okay, let's put 3 only. Okay, how many spanning trees we got for this graph G? We got 4 spanning trees. One was this, other was of this format, Another was one like this, another one was like this. By removing one edge at a time, we got 4 spanning trees. What is cost of this spanning tree? You count 2 plus C, 2, 3, 3. The cost is around 8. Now, if you take this spanning tree, it is 4, 3, 3. That is 10. If you take this one, it is 2, 4, 3. That is 9. If you take again this one, 4, 2, 3. So 5 plus 5, 9. Among those 4 spanning trees, which spanning tree is having minimum cost, minimum weight? This one, right? Because it is 8. Okay, this is 8, right? So the problem here is, given a graph with some weight, find out the minimum spanning tree among all the possible spanning trees, among all the different combinations. If you remove one edge, you get one spanning tree. Remove another one, you get another spanning tree. Among all those different spanning trees, which one gives me the minimum cost? Okay, that is the concept of spanning tree. So we need to find out the minimum spanning tree for a given graph, for a given weighted graph. We have to find out the minimum spanning tree. Means a graph G can produce multiple spanning trees. It can produce multiple spanning trees. Among those spanning trees, which one will give me of lesser cost? That we have to find it out. So that is the problem here. Minimum spanning tree. Finding out a spanning tree which will give me the least cost. So there are 2 algorithms in this concept. One is Prim's algorithm, second one is Kruskal's algorithm. So these 2 algorithms helps us in identifying the minimum cost spanning tree. Okay, minimum cost spanning tree. It is also called as minimal spanning tree. Again, all those minimal, minimum, all those concepts comes here, right? So what is this task here? Given a graph G, given a weighted graph G, find out the minimum cost spanning tree from that graph. What is spanning tree? It's a subgraph of that graph, which is a tree. It's a subgraph which is a tree. The condition that tree should have all the vertices which are available in the original graph. Okay, so there are 2 techniques to find out the minimum spanning tree. First one is Prim's algorithm and second one is Kruskal's algorithm. Let's apply one by one for this problem and try to find it out. So I am applying now Prim's algorithm. Okay, Prim's algorithm. Prim's algorithm says that always choose the adjacent vertex. Always choose the minimum cost adjacent vertex. Always choose the minimum cost adjacent vertex. Right. So let me know what is the if you go back to the definition of spanning tree. Spanning tree is a subgraph of the given graph G which has all the vertices and it should be connected. So let me draw these vertices 0 and 1, 2, 3, then I have 4 here, we have 8 and we have 7, 6 and 5. I have drawn all the vertices. Now, how should we begin? You begin from any vertex wherever you want. Let us begin from 0. Let us begin from 0. So, if I begin from 0, how many options do it have? It has 2 alternatives. One with weight 4, another with weight 8. Okay, 0 has 2 paths. One with weight 4, another with weight 8. Now, among these 2, which one is of less cost, less weight? 4 is of less weight. Then draw that particular edge. So, it becomes 4. Now, from this you remove the 4. It has only 8 now. Okay. Now, we got a new vertex 1. From 1, how many paths do we have? You write it out. So, you have, see, one path is 4 which is already covered, which is already gone. The other one is 11, the other one is 8. Okay. One is 11, other is 8. So, 8, 11. Now, among these 3 weights, which one is of less cost? Which one is less cost? There are 2 8s which are same. You can take any one of them. You can choose any one of them. So, I will choose this. You can choose any one of them. No problem. I will choose this. So, this 8 also has gone. It means the node 0 has gone. Now, there are nothing to do with node 0. So, I have left over with 1 and 8. But see, we got a new vertex into the tree, that is 7. Now, what are the alternatives for 7? See, 7 has one alternative 8 which is already covered. Then other one is 1, 7, 11. It has 3 alternatives 1, 7 and 11. Now, among these full 1, 7, 11 and 8, 11, which one is the minimum cost one? 1 is the minimum cost one, that is from 7 to 6. I will connect this and I will put 1 here and erase this 1 from here. Over. Now we got a new vertex 6. So again, write down here 6. What alternatives it has? It has 1 which is already covered, it has 6 and it has 2. It has 6 and 2. Now, among the alternatives of 7 and the alternatives of 1 and the alternatives of 6, in all these set, which one is the minimum cost one? 2 is the minimum cost one. So that you have to include. It is from 6 to 5, 2. So erase this 2 from this now. Next, so we got a new vertex 5 here. So put 5 and list down its alternatives. One alternative for 5 is 2, that is gone. So we have 4, 10, 14. We have 4, 10 and 14. Okay. Now which one among these 7, 11, 8, 11, 6 and this, which one is the minimum cost one? 4 is the minimum cost one, that is from 5. So from 5 to 2, that is the minimum cost one. Put it there, 4. Now this 4 is removed from here. Okay, 4 is removed from here. Sorry. Right. Oh, just a second. Yeah. Okay, now we got a new vertex 2. So we got a new vertex 2. So what are the alternatives from 2? From 2 there is an alternative 8, which is 8 is pending, 8 is free to take, then I have 2, then I have 7. See, one is 8, other is 7, other is 2. 4 is already covered. Now among this full set of weights, 7, 11, 8, 11, 6, 10, 14 and 8 to 7, 2 is the minimum one, that is from 2 to 8. Put it that. So this 2 is also removed now. So we got another vertex 8 here. We got another vertex 8. Okay. So from 8, what are the alternate options? From 8, one option is 7, other option is 6. 7 and 6. But if I from 8, if I link this, it is forming a cycle. Tree should not have cycle. So I cannot combine this 7. And if I club this 8 to 6, again it is forming a cycle. So I need not use this. So I will not use the 8. It's gone. Now, among these alternatives, which one is of minimum cost? You find it out. Among these alternatives, which one is of minimum cost? See, 6 to 6. From 6 to 6 is the minimum one. But if I club this 6 to 6, it is forming a cycle. It is forming a triangle. So this is also removed now. I don't want this also. Next, among all these, 7 is minimum. There are 2 7s. One from 7, one from node 7. Where is that here? From this 7, if I link, again that is forming minimum. That is forming a cycle. So I will remove that also. Next, I have another 7 from 2. From 2 to 3. Yes, this can be formed because it is not forming a cycle. That is the minimum one. Now, I got a new vertex 3. From this 3, what is the alternative? 14 and 9. But if I connect 14, it is forming a cycle. You see, if I put 3 to 5, 14, it is forming a cycle. This triangle is forming a cycle. So the only option available is 9 for me. Okay, now among these, which one is minimum? 8 is minimum, that is from 1. From 1 there is one 8. Yes, from here there is one 8. Where is that going? Where is 1 here? But if I connect this 8, it is forming a cycle from 1 to 2. This if I form, it is forming a cycle. So I will remove this 8. Then I have another 8 from 2. Where is that 2 node here? From here, this is the 8. So again it is forming a cycle. I will remove this. 2 to 7, I already included. I have to remove this. So 2 is also gone. Now in the leftover things, which one is the minimum one? 9 is the minimum one. That is from 3 to 4, 9. That's it. We got a graph now which is connected, and right, we have connected the graph. It is a tree and there is no cycle and all the vertices are covered in that. Okay. So this is the approach of Prim's algorithm, right? Always finding out the alternatives. So what is the cost of this tree? What is the cost of minimum spanning tree? Is sum of all these weights. So 4 plus 8, 12 plus 1, 13, 2, 15, sorry, 15 plus 4, 19 plus 2, 21 plus 7, 28 plus 9. So it is 37 is the cost of the spanning tree. So this you have to find it out. What is the minimum spanning tree and what is its cost? That we have to find it out. So this is Prim's algorithm. Okay, let's solve another example and apply again. Same, let's apply Prim's algorithm again on this graph. Okay, so let's apply Prim's algorithm on this graph. Okay, so let me note down the vertices A, B, D, H, and here we have F, E, C, G, and I have I here. Okay, so these are the vertices we have here, right? Just forming the graph. We are applying Prim's algorithm. PRIS, Prim's algorithm. It always says select the adjacent vertices. Okay, right. Now you can start from any place. Let me start from A. From A, there are two alternatives, 1 and 6. There is one edge with weight 1, another edge with weight 6. Which one should I select? The least one, that is 1. So I will select this 1. So this 1 is removed from here. So 1 is removed from here. So left out is only 6. So we got a new vertex B. We got a new vertex B. From B, what are the alternatives? One path is going to D, other path is going to F. So 3, 5. Now among these weights, 3 weights, which one is the smallest one? 3 is the smallest one. So it is between B and D. So let's put here 3 like this. Okay. So this is gone. Now the tree becomes simply like this, 5. Next, we got a new vertex D. So I have D. So what is the alternative from D? From D there is only one alternative, that is 7. Now among these 3, which is the minimum one? 5 is the minimum one. So that is between B to F, 5. Now this B edge is removed. We got a new edge F here. We got a new vertex F. From F, what all options do I have? I have 8, I have 3. So one is 3, other is 8. So among all these, which one is the minimum cost one? 3 is the minimum cost one. That is from F to E. So I will connect this as 3. So this 3 is removed. So I am left over only with 8 here. Next, I got a new vertex E. From E, what alternatives do I have? One is 2, other is 2. 2 and 2 are the alternatives. Why? This 3 is already covered. This 3 is already covered. So I have 2, 2. After adding this, among all these weights, which one is minimum one? Both these 2's are minimum one. So I will try to connect this 2 here. So this is gone. So only E contains only one edge with weight 2, which is pending. Now I got a new vertex C. From C, what are the alternatives? One is 6, other is 8. One is 6, other is 8. So it is 6 and 8. But if you see, if I connect A and C, it is forming a cycle. See, this is forming a cycle here. So I should not include 6. Again, if I include 8, again it is forming a cycle like this. So I should not include 8. So I cannot proceed with this C. Okay, so even after adding C, I cannot do anything. Now among this leftover, which one is the smallest one? 2 is the smallest one. That is from E to G. Let me put 2. Now we got a new, so this 2 is also gone now. So complete edge E is removed. Now you have the edge G. What are the alternatives from G? One is 4, other is 9. 4 and 9. Now among all these available options, 4 is the minimum cost one. That is from G to I. So G to I, that is 4. So this is gone. I am left over to 9. Now I got a new vertex I. So I, what are the alternatives from I? One alternative is 3 because 4 is already covered. Now among all these, which one is the minimum cost one? 3. So let me connect that 3. Okay. See, now we are completed. We have connected all the vertices. We have connected all the vertices, and it's a connected graph. It's a connected graph. It's a tree. There are no cycles. Okay. Now you have to once you complete, you have to check whether from each vertex do I have a path to all the other vertices. See, from A do I have to path to B? Yes. From A do I have to path to C? Yes. This way I can go. I have a path. From A to D, yes. A to E, like this. A to F, yes. A to G, I can still go here. And A to I also I can go here. A to H also I can go here. Like this, from every vertex there should be a path to all the other vertices. Okay, so this is the, now what is the minimum cost of this tree? If I just delete this, what is the cost of this tree? See, 1 plus 3, 4 plus 5, 9 plus 3, 12 plus 2, 14 plus 2, 16 plus 4, 20, 23 is the minimum cost of this spanning tree. It is the cost of this minimum spanning tree. Okay, so this is the Prim's algorithm, right? You have to always choose the adjacent one and make sure that there are no cycles. Okay, it should be a tree and all the vertices should be covered, right? So this is about Prim's algorithm. In Prim's algorithm, always we go for the adjacent vertices. The next one is Kruskal's algorithm. The next algorithm is Kruskal's algorithm, which is very easy. This is more easier compared to Prim's algorithm. Let's try to apply Kruskal's algorithm for this graph. Kruskal's algorithm. How do we solve this? Again, let me list down these vertices: 0, 1, 2, 3, 4, I have 5, 6, here it is 7 and 8. So these are the vertices I have drawn. In Kruskal algorithm, you have to choose the random weights. You have to choose the random low cost weights. Okay, choose the random low cost weight, meaning it means that in this graph, among all these weights, okay, which one is the minimum cost one? Directly you can see one is the minimum cost one. That you draw it first. Okay, in the whole graph, find out the minimum cost edge. Find out the minimum cost edge. So in this graph, I could see one is the minimum cost edge. This one. So I will draw it between 7 to 6. Then what is the next minimum cost one? I have 2 here. I have 2 here. These two are. So both, before you have to, but always you have to check, is it forming a cycle? That you have to check. Is it forming a cycle? No. If I include this, it is not forming a cycle. If I include this, it is not forming a cycle. Then what is the next minimum cost one after 2? Do I have 3? No. Do I have 4? Yes. There is one 4 here. There is another 4 here. But if I include that, is it forming a cycle? No, it is not forming a cycle. If I include this 2 to 5, is it forming a cycle? No, it is not forming a cycle. Next, after 4, which is the next highest one? 5. Do I have 5 here? No. Next to 6, yes, I have a 6 from 8 to 6. But if I include from 8 to 6, it is forming a cycle here. So I cannot include 6. Go for 7. If I include this 7, it is forming a cycle. You see, it forms a cycle like this. So I cannot go for this 7 as well. So another 7 is here. Yes, I can connect them. It is not forming a cycle. Next, which is the next weight after 7? 8. There are 2 8s. One is here, another is here. So are they forming cycle? No. If I connect this like this, it's okay. It is not forming cycle. But if I connect this from 0 to 7, it is forming cycle. Don't do that. So 8 is also over. Next, what is the next minimum cost one after 8? 9. Where is 9? Here. 3 to 4. Connect this. 9. That's it. We are end. We can see that I have connected all the vertices. I have connected all the vertices in the graph. You can check the previous one using Prim's, it was 37. Now also you can verify 4 plus 8, 12 plus 7, 19, 19 plus 9, 28 plus 2, 30, 34 plus 3, 37. Still using Kruskal's algorithm also we got 37. So these two are different techniques. Either you can use Prim's or you can use Kruskal's. Whichever you want, you can use it, but the minimum cost will be same. Okay, so this is the approach of Kruskal's algorithm. Randomly choose the minimum cost edges and place them in the graph. Right? So you have to find out this cost and also you have to show this tree like this. So this is the approach of Kruskal's algorithm. Let's try to apply for this same problem again. Let's apply Kruskal's algorithm and see what is the output of this. Okay, so again I will draw the vertices here: A, then B, D, H, F, C, E, G and I. Okay, now among this whole graph, which is the minimum cost one? 1. So I will draw it 1 here. Then the next minimum one is 2, 2. There are 2 2s. I can easily connect. They are not forming cycles. Then is 3. Yes. How many 3s are there? Say there is 1 3 here, then another 3 here and another 3 here. All 3 I can connect. They are not forming the cycles. This also not forming cycle. This also not forming cycle. Next highest one is 4. Where do I have 4? Yes, I have a 4 here. Is it forming a cycle? No. I can connect this. Then the next one is 5. If I form B to F, is it forming a cycle? No. I can connect this. It is not forming a cycle. Next to 6. That's it. We have reached the end. We are connected the graphs. We have connected the whole graph. So it's very easy. Randomly choose the minimum cost one, connect it. Okay. Keep increasing the weight. Then 1, then 2, then 3, then 4. The next available minimum one, you keep adding it. Once after a certain point, you will realize that you have connected all the vertices. Some connection has been formed. A chain has been formed where there should be a path from each vertex to all the other vertices. From E, if I choose this E, I can traverse, I can reach A, I can reach B, I can reach C, I can reach D, I have path to F, G, H and I, everything I have it. Though you have to stop and find out its cost. See 4 plus 5, 9 plus 3, 12 plus 12 plus this 4, 16 23. Same thing we got previous also, right? So this is the Kruskal's algorithm. I'll just differentiate between both of them. In Prim's algorithm, we always choose the adjacent vertices only, whereas in Kruskal's algorithm, you can randomly choose the minimum cost ones. Wherever there is minimum one, that you pick up and plot in the graph, so that you form a tree. Okay, so these two algorithms are very popular algorithms to find out the minimum cost spanning tree. You are able to find out the tree, as well as you are able to tell the minimum, what is the minimum cost of that tree. Okay, so this is about the spanning trees concept, right? Thank you.